My name is Craig Picken. I'm an executive recruiter. More than a decade ago, I started my practice for one purpose: to use my experience as a former military aviator, business jet sales executive, and P&L leader to help aviation and aerospace companies and their executives be fast, adaptable, and strategic. I do these podcasts to inspire and inform, but more importantly, they are a focused platform to help business leaders grow. Welcome to the Aerospace Executive Podcast. Hey, welcome back to the Aerospace Executive Podcast. I am thrilled to have Mark Ozenick with me. Mark is the CEO of a company called Rotorcraft Newco. I've known Mark for the better part of a decade. He's the founding entrepreneur for Heliflight, which is a helicopter transportation service up in New York. And I've also got Peter Schmidt with me. Peter is the COO of Transcend Air. And for you following the VTOL market, Transcend Air is developing a prototype aircraft. It's a tilt wing aircraft to meet a new generation of VTOL and urban mobility needs. So hey guys,
howdy.
Welcome on board. Thanks for coming today.
Thanks, Craig.
Thanks for having us, Craig.
So, a lot of news. Let's talk about this first. There's a lot of news out there right now about urban mobility, and there's a lot of people coming into the market using battery powered or electric powered air vehicles. You're bringing a different concept to it with your product, PT6 powered or GEC T700 powered type aircraft. What's your vision of urban mobility now and for the next 20 years?
Let me talk about two different markets. Excuse me. So let me talk about two different markets. There is a purely urban market where you're moving people across a city or a metroplex, and then there's a city-to-city market. Urban planners tell me that the world is evolving into an interconnected set of mega city regions that actually where the trade within a larger set of cities is becoming more and more important. So the Northeast in the United States is a huge mega city region from Washington, D.C. up through Boston. And serving that requires, with a VTOL aircraft, requires an aircraft with a 500-mile kind of range, not a 50-mile kind of range. So we set out to take what's a proven existing travel market, which is business travelers and leisure travelers going from one city to another, and serve that with a novel VTOL aircraft. The aircraft we've called the Vi-400 because it goes 400 miles an hour for 400 nautical miles. And what that aircraft lets us do is it lets us break through the barriers of congestion that are currently choking the growth of transportation in these megacity regions. By moving the transportation resource closer to the demand. So what do I mean by that? Right now, if you want to fly somewhere, you have to go to an airport and you spend a lot of time in an Uber or a taxi getting there. Then you wait in line at a parking garage, you wait in line at security, you wait in line at the gate, you wait in line in the aisle of the airliner, and then the process goes in reverse to get somewhere. So even if the flight in this area is only 30, 40 minutes, your door-to-door time is 4 or 5 hours. Right. So the way we bust through that barrier is we take smaller aircraft and barge-based floating landing pads, and we put them in the waterfronts of major cities, and we bring that transportation resource near to where people's office buildings are. So a great example is the Wall Street Heliport in Manhattan. So Wall Street Heliport is a 15-minute walk from the stock exchange, and it serves hundreds of takeoffs and landings per day already. And so we envision scaling that up. And that's how I met Mark originally.
So Peter, let me just kind of add to that, if you will. So in 1998, I founded Heliflight Shares. And Heliflight Shares business model really hasn't changed in 2 decades. It was set up to do regional transportation using rotary wing aircraft. And the rotary wing aircraft we decided to use were we'll call all-weather 2-pilot cabin class aircraft. And typical flights that we do New York to Washington, we do New York to Philadelphia, we do New York to Boston, and we do New York to the Hamptons and private residence. So when I first found out about Transcend and the Vi-400, I felt that aircraft, because it was being designed by Peter and his business colleague, Greg Brule, who have looked at this from the ground up and how to make money in this business, have come up with just a killer design. And my opinion is that the Vi will step in as the game changer, kind of as the paradigm shift platform to allow greater distances to be traversed at less time at a lower cost, therefore making the operators more money. And that aircraft, in my opinion, could serve what's being considered today as the urban mobility market, which is the inner city, let's say inner Los Angeles or inner Bay Area or Sao Paulo or London, Paris. So the aircraft offers more mission capability at a price point that makes money.
Yeah, so excuse me. Let me jump in on that too, Mark. So we designed this aircraft to go from one city to another. And to compare to current helicopters, if you fly one of these medium twin helicopters, cabin class executive aircraft from Boston to New York, the minimum price you're going to have to charge for that per seat is on the order of $600-700. And that's a lot of money for people. It's not competitive with getting on the Delta shuttle, even when you take into account the cost of getting in an Uber to and from the airport. So that's why you don't see a mass market in this sort of helicopter transport right now. It's just the price point's too high.
Right.
With our aircraft, we designed it to a price point that would be competitive. So on our canonical Boston to New York route, we can offer an average price of $283 one way. Now, that is obviously less than half as much as the best you can do with a helicopter.
Mm-hmm.
It turns out also to be less than an Uber to Logan Airport, the Delta shuttle to LaGuardia, and an Uber to Wall Street. So that's what unlocks mass market for us with this aircraft. And the economics of it are just, when you're flying on a wing, you're more efficient.
Yep.
So that's what we designed it for originally, was this city-to-city market. And Mark was the one who said, hey, based on my experience at Heliflight, I really think that this aircraft can apply in the urban air mobility, the within-city mission.
Mm-hmm.
So we've done some modeling of that. And it turns out that for the kind of airport transfer service that Uber is doing now with Heliflight and that Blade has been doing with AAG, the Vi turns out to be the cheapest alternative there is right now. Right. It's cheaper than doing it with a little Robinson R44 piston helicopter. It's also cheaper than proposed electric eVTOL aircraft. I mean, there's enough public data out there that I was able to model in an all-electric eVTOL on that mission. And it really suffers because of the limited payload. That means few passengers. So it ends up being as expensive as flying an AW139 with 2 crew.
Peter, if you have a moment, why don't you describe to the audience what the Vi 400 is?
Yeah, so the Vi 400, you can describe it a couple different ways. From a market perspective, when we certify this aircraft, it will immediately be both the world's fastest helicopter and the world's fastest single-engine civil turboprop. So what does that really mean? It's a 6-place, turbine engine powered, mechanical drivetrain, 2 main propeller, single electric tail fan, tilt wing, vertical takeoff and landing aircraft. So that's a big mouthful, but technically
there's a lot going on there.
There's a lot going on there, yeah. So the aircraft, you can think of it as having been enabled by 60 years of technology development since the 60s. Especially better structures manufacturing technology, higher power to weight jet engines, and fly-by-wire flight control.
Okay.
So from a aircraft nerd perspective, those are all key innovations that allow us to take the tilt wing platform, which was flown successfully in the 1960s by several companies, the CL-84, Canadair, the XC-142. These were successful aircraft that flew well, but they weren't adopted for various economic and political reasons at the time. But part of that was performance reasons, which have been overcome by these technology advances. So our aircraft gets to benefit from 60 years of better power to weight.
Right.
A key factor in the enhanced safety and performance of our aircraft is the advent of the whole airframe parachute, which Boris Popov and Ballistic Recovery Systems invented 20 years ago, and has been flying for almost 20 years in Cirrus light piston aircraft, and now the Cirrus Vision Jet.
Okay.
So a whole airframe parachute means that if anything really bad happens, a parachute pops out of the aircraft and the whole thing floats down to the ground safe.
Right. Much like the Cirrus has, but you've got the interesting thing about the tilt wing is the V-22 started out as there's a lot of learning. There's a huge learning curve.
Yep.
With the V-22, but now it's become, a game changer for, the Marines and Special Forces, and the technology is proven.
Well, let's talk about that for a second, Craig, if I may. So the V-22 is an excellent platform. It's a great platform, but it was designed for a military mission.
Right.
And the Bell 609, or now the Agusta Westland 609, the technology really is the same. They just scaled it down. But there's so much complexity in that design, it drives high acquisition cost and high operating costs.
Right.
Yeah.
And it's not really optimized for what we'll call Rotorcraft Newco would like to see as an operator of these from a price standpoint. If you were talking about the Agusta Westland 609 tilt rotor as a $22 million aircraft.
Right.
And we're thinking about a price under $5 million.
Yeah, well, I think that's where I was getting to, was that I think what you're talking about is that the technology, yours is not a revolutionary technology. It's more of an evolutionary technology.
Right. Exactly right.
And you talk about, can you build it for $6 million and still be profitable? I mean, that's the,
yeah, absolutely.
That's the question is that, when I look at the price point of a Cirrus today, just a Cirrus SR-22 is
$800K,
pushing $1 million. You guys are starting to talk about, twin engines and twin props and a single engine.
Yeah.
Can you build it?
Oh, we can. And so the comparables to look at are, so like I said, it's a single engine helicopter or it's a turboprop.
Mm-hmm.
So you look at the prices for representative aircraft in that class that are the sort of same size. And so we fit right in. In fact, in base trim, the aircraft price would actually be more around $3.5 million. So that's less than a Pilatus. It's less than a King Air. It's about the same as a TBM. It's a bit more than an H-125. It's about the same as a Bell 407.
Right.
We've shown our design and the bill of materials that we have for that design to several airframers now.
Mm-hmm.
And they've all said, yeah, that's about right. And in fact, there's an aircraft designer friend of mine pointed out that there are a couple sort of laws, if you will. They're really correlations, but they apply broadly to aircraft. And one is, you can take the length of an aircraft, and that's going to pretty much determine its empty weight and its max gross weight, and also its cost to a very large degree, because everybody's using the same aluminum or carbon fiber. Everybody's using the same turbine engines. Air doesn't change for anybody else.
Right.
Everybody's trying to minimize weight for their operating. So you end up with this, this curve, which is basically a straight line.
Right.
And you can apply that. And I've done that. I have a blog post where I compared our aircraft to TBM, a Cessna Caravan, a Pilatus PC-12.
Mm-hmm.
And we fit right on that line.
Okay.
And interestingly enough, there's some other designs out there that do not fit on that line, which makes me really think that those designs are not going to work.
Well, it's part of it's like I said, we talked about this before we started recording, the G700. All of a sudden now you're talking about, 7,000 miles at Mach 9.2, fast airplane, big fast airplanes, the Global 7500, same thing, all this, the cabins are all now pushing 737 sizes. I mean, literally now you go any more, you're into a BBJ. What's the next evolution in business jet travel? And is it a stand up light jet, a light jet with a comfortable cabin, or is it a point-to-point airplane, much like you guys are proposing with your Vi 400, that gets somebody from the Wall Street heliport to downtown DC, or at least Reagan National,
I think it's
without going to Teterboro.
Yeah, Craig, obviously we think it's the point-to-point aircraft, and here's a couple scenarios. So let's say that you have your G550 on the ramp at Teterboro on a Friday afternoon, and you get out to the airport after a black car ride or a limo ride out to Teterboro, you have to wait an hour plus for your clearance to get out. And let's say that you're going to go to Chicago, or you're going down to Philly, or going to DC, or even points further than that. It's terribly inefficient from a time perspective, and that's why you have that asset, is to get out. So the VI Rotorcraft Newco's model, using Rotorcraft initially and then the VI later, which is our plan, really opens up the opportunity to have transportation options that are more, we'll call it, useful of time, useful of a company or an asset's time. So we think the VI will not only do that city to city, but the interurban airport transfer stuff much more efficiently, and give an operator an advantage. So let's say you're in New York, and you instead of leaving Teterboro, you could leave Stewart. So you could hop in one of the Rotorcraft Newco helicopters, or in the VI, and get up to Stewart in a matter of minutes, and then you can be on your way without it. So the VI really will de-stress the ATC system, by putting more of the regional transportation at say like a flight level, 120 or a flight level 150 on those regional trips. Rather than having jet traffic compete for that limited space. And also those airport slots. And Peter, I think you might want to add to that.
Yeah, no, I mean, it's the concept to me makes a lot of sense. I mean, I think where I've been struggling with a lot of the urban mobility market is, when I look at what Uber is trying to do with, or Cora, or some of these other companies with the electric powered air vehicles, nobody to me has defined what urban mobility is. Is it Susie going from her home to the grocery store? Probably not. Is it going from downtown New York to JFK or LaGuardia? Mark, you already know that. You already know that market with Heliflight shares. I think you guys, what you guys are saying is, hey, look, a lot of the air traffic, that we talk about, especially LA to Las Vegas, LA to the Bay Area, which requires a drive to now, Burbank or Orange County or LAX with a, flight. You eliminate a lot of that hassle, and the technology's coming on strong. What do you think it costs to get this thing time-wise? Time to development?
Well, there's two different pieces. So there's getting the VI aircraft certified and entered into service. There's also standing up Rotorcraft Newco and having that as a platform.
Right.
So, in terms of the VI, we've got a few $1 million in seed funding to have gotten us to this point. And it's no secret that our next phase is our Series A round to build a full-scale manned prototype aircraft. We're currently flying 5th scale prototypes that are the 15th in a lineage of flying prototypes, including 2,000-pound manned prototype that we built and flew at a predecessor company. So, we've been doing this for a long time. Depending on you count, it's been over a decade now. So we're getting there. So, there's some tens of millions of dollars to get flying prototypes to prove the concept definitively. And then from there, it's hundreds of millions of dollars to get to production certificate and type certificate. But it's less than what the eVTOL companies are looking at. And the reason for that is certification costs are driven by how much you have to test and prove is safe.
Right.
Our aircraft uses literally all off-the-shelf components, except for the specific software implementing our flight control laws and the specific gears in our 3 gearboxes. But neither of those are cutting edge from the standpoint of we're inventing something nobody's ever done. We're just doing a different version of stuff that already exists.
Right.
And this is key to the economic value proposition. There have been a lot of cool aircraft designs that never made it into production because they didn't have the right value proposition. There wasn't going to be enough value, or they were just too costly to certify and you couldn't get there.
Right. Well, the Eclipse was one of those airplanes. I mean, the Eclipse look, it was a neat little concept. I was never real, I was never a real fan of the quote unquote VLJ.
Yeah.
Eclipse was was a cool concept, but it really couldn't carry any payload, and it didn't have any range. And you could sit there and see it was going to be $3 million by the time it was all said and done.
All said and done, yeah. And so we learned from that. I mean, I have the stripes on my back from that aircraft specifically.
Right.
I came into the industry trying to make money with Eclipse jets, and can't be done.
Yep. No. And 200 of them are built, and it was it's
fun. It's a really fun aircraft to fly around. But what happens with these waves of economic innovation is and I saw this in high tech, but I can point to this example in aviation, is that people get excited about the potential of some new enabling technology. And I think what's driven the Uber and the urban air mobility electric VTOL space, quite honestly, was people getting DJI drones under their Christmas tree.
Yeah, I agree with you. I agree with you.
They're like, wow, scale this up. We can put people in it.
Right. Right.
And it's not that simple. And B, we absolutely agree that the future of aviation is electric. No question. But, Xerox built a personal computer in the 1970s with a 3-button mouse. Mm-hmm. Xerox is not Apple, right? They're the pioneers with the arrows in their back.
Right.
And Eclipse kicked off, they were the most notable and sort of the stone that started the avalanche of VLJ activity in the mid-2000s. Mm-hmm. You know what aircraft ends up as being the only successful VLJ to market? Cirrus Vision Jet.
Yep.
Over a decade later.
Yep.
And that's because Dale and Cirrus were brilliant in understanding a market, and it's SR-22 pilots who want to upgrade to higher performance and speed.
Right.
They built their own market, and then they created an aircraft to serve it. That was brilliant. The notions behind that powered the VLJ market were, from an aircraft standpoint, veteran insiders looked at it and knew that's not $1 million aircraft. It's a $3 million aircraft.
So Peter, let me add to that if I may.
Yeah, please.
So we were trying to talk about earlier, Craig, what's urban mobility, and it's this kind of nebulous concept right now that's been really been advocated by Uber. It was obvious to me when we put Rotorcraft Newco together that none of the airframers really are talking to operators. Who are the operators of this? Yeah. What are they going to use it for? What's the market? What's the customer demographic look like? What are people willing to pay? How do you segment the marketplace? So Rotorcraft Newco has done all this, right? So in the United States, Rotorcraft Newco, which is an acquisition platform to go out and acquire VVIP helicopter operators. And we have a significant amount of money behind us, over $100 million, to go out and acquire companies, is going to help define what urban mobility is and what platform is best suited to that market, whatever that market is, turns out to be, and how to make money in it, and how to provide safe and reliable transportation to that customer base. So this is why my interest in Transcend came to light, because Transcend has always said, look, we want to develop the concept. We want to go through a strategy very similar to what Arion did with Bass Family, right?
Yep.
The license production, certification production to an airframer. That's Transcend's model. Transcend and Peter and Greg, who founded Transcend, really don't want to build these aircraft. They want to license, they want to operate them. So that's how Peter and Greg and I came together as kind of like-minded executives that are going to take what will be the Vibe 400 in the future and actually have another airframe build it, and we'll buy it and operate it.
Well, yeah, look, and Peter, much to your, as we talked about earlier, you think about, I could have urban mobility today with an R44. I just can't make any money off it. It exists, and I could go get an R44 for probably $700,000 and fly it between John Wayne and LAX and go broke in the meantime. But
and people do.
And people do. Now the technology is such that it's not even the technology. It's like you say, you're doing it off the shelf type. What do you think your plan is? You're going through your Series A. You've got some investors. and you've got some deep pockets behind you.
Yeah.
Do you develop the platform? Do you develop, the aircraft and then get a Gulfstream or a Textron involved in it to take it to the next level? Do you try to do it yourselves? What do you what do you think the future Transcend looks like in 10 years?
Yeah, no, that's a great question. So as Mark said, we don't want to be the aircraft manufacturer. We want an experienced aircraft manufacturer with all of the plant, personnel, equipment, relationships with the FAA, track record of successful certifications to invest in our program, to actually take it over and manufacture and certify it, and then sell it to us. So one way to look at this business model is it's like the Ariane model, or it's the Apple model. Apple doesn't manufacture their hardware. They design it.
Right.
And then they sell it to people, and then they offer downstream services.
Mm-hmm.
So that's our model. So, our vision is to offer the downstream services. And what turns out to be a bit unique about how we developed this aircraft is we started with a price point, and we designed the aircraft from that. And so we didn't start as aircraft enthusiasts or aircraft manufacturers. As Mark said, it keeps surprising us, but aircraft manufacturers don't talk to operators. Mark just talked to one of the major eVTOL contenders to get a briefing on their aircraft. And we said, okay, are the battery packs swappable in operation?
Mm.
And they said, no. And we're like, okay, then it's impossible for us to make money with your aircraft.
Yeah. It's got to sit for how long does the airplane have to sit while in between flights to recharge? I mean,
and it can only, in my model, by the way, I said I modeled an eVTOL transfer service. I assumed that aircraft had 5 swappable battery packs. So 1 in the aircraft, 2 at each end, with a charging to leg flight time interval such that you could keep swapping and go continuously. I mean, if I can't go continuously, it cuts the number of trips that capital equipment can do down from maybe 9 a day to like 2.
Right.
It's just silly. So I'm sorry for being indignant, but having come from an operator background, you know what another one is? I look at some companies publishing economics for their proposed aircraft. They don't have any landing fees in their operating costs.
Yeah.
Like, excuse me, that's the whole reason airports exist, is to charge you landing fees.
Right.
That's their revenue model. So getting back to where we're going to go. Our goal is, I should say, to close our Series A this year, get the prototype program going. And if all goes according to a plan, which is a realistic plan, entry into service will happen in 2025.
Okay.
And we want to go after 2 markets with the aircraft. We want to go after the market served by Heliflight that Mark knows so well, and that Rotorcraft Newco is going to be going after, which is the proven profitable market for operating rotorcraft, which is VIP service.
Mm-hmm.
And then as the VI comes online with its superior operating economics, there's an opportunity to expand that market by having it be somewhat more affordable.
Right.
And then, of course, the other thing we want to go after is the airlines and Uber. By taking money away from airline tickets and ground transportation, we can offer a price competitive service for some niche of the already proven city-to-city business travel market.
What about just the guy who flies a light jet now? I mean, how many, I was talking to Brian Foley a couple of weeks ago, and he said that the market for Ariane was 300 aircraft over 10 years. What about just the guy who's, looking for his own, light aircraft to replace his Lear 31 or his Beach Jet or his Pilatus or whatever he's flying now?
What do you think? We'll sell some of those. We'll sell some of those, but we're really targeting people to buy helicopters today.
Okay.
Because in order to achieve the goals for this aircraft, so here's one of the lessons we learned looking at other aircraft programs, were that your typical aircraft program, both military and civil, gets worried about selling enough units, and they try to expand their missions too early, which adds too many requirements, many that compete with each other, which increases certification cost and risk, and you tend to end up with compromised designs that don't do anything really well. So we're like, okay, we're going to avoid that because we know that this airline mission is a $20+ billion market in the US alone. So we don't need to go chasing other requirements, and we haven't. But what that means is, when you get excited about the idea of vertical takeoff and landing, there's no free lunch in engineering, right? This isn't magic. So what are you trading for vertical takeoff and landing? Well, in our case, you're trading range. We made the aircraft fast, but it doesn't go very far. It only goes 400 nautical miles, right? So if you have a fixed wing aircraft, my tenure in business aviation taught me people buy their fixed wing aircraft for that 10% mission. Even if the vast majority of their missions are 400 miles, twice a year they load up the family and they fly to Vail or they fly to Whistler, and they justify that purchase in their heads and with their wife on that basis. So they can't buy something that can't do that mission. So I don't really expect people to get out of fixed wing biz jets and get in a Vi. I do expect them to get out of helicopters and get in a Vi.
And Peter, I expect that the Vi would be a great, we'll call it fractionalized aircraft option, where if you need that flexibility and you can own a fraction in it, or you can buy a card in a program, this is what Rotorcraft Newco is contemplating, or just on-demand charter, that really works because it's a mission multiplier. Yeah,
well, talk about how you saw people buy that at Heliflight.
Yeah, exactly. So we had many people that owned large cabin aircraft, Challengers, Gulfstreams, Falcons, that didn't want to fire up the Falcon 2000 to fly from Teterboro to the Hamptons. They didn't want to drive. So the helicopter was a great product, and it was at a price point that the customers found value. And that price point was, about, north of $6,000 an hour.
Yep.
And, we can make money at that price point. So it's interesting that, we found corporations that had large cabin jets that needed that regional point-to-point capability that were either buying fractional interest in Heliflight or a helicard or just doing on-demand charter with us. Because we trained our pilots and had our op specs written to a level that matched theirs. So safety, service, quality of aircraft really worked very well for us. And where a flight department or individual would be reluctant to buy a helicopter because of the capital costs, the operating costs, this really worked out really well.
Yep.
We think we'll see the same thing for the Vi, for those kind of individual uses.
Well, like I said, it comes down to the turbine powered. The technology is already there. It's just how do we put it all together and make the mission work. Last question. So the Hamptons getting a little bit they're getting a little uppity up there with the environmental issues. How do you overcome the ancillary stuff that has nothing to do with the airplane, but has everything to do with the PT6 uses JP5 and some of the environmental issues, the noise issues, and things like that.
Let me address that, Peter, if I could, please. And Craig, that's a great question. So aviation's had that problem since the airplane was invented, right? So I think it's a matter of being transparent with the public and municipalities. And so the Hamptons, for example, we already have a very strong fly neighborly program in place for operations in the Northeast, specifically out to the Hamptons, where there's specific helicopter routes at specific altitudes to limit overflying populated areas and minimizing noise impact. If we were to take, or when we take this product to the West Coast, we'll do similarly, all right? And make sure that we work to fly neighborly. The Vi 400 is an interesting aircraft because it offers an additional performance capability where you can actually, say if you're leaving East Hampton Airport, you can get up high very quickly, okay? And you can be at a higher altitude when you transition out of the airport airspace. And that really minimizes the noise. And just by definition, the Vi, as a tilt wing aircraft, has a less noise footprint than a helicopter does. And Peter, want to add to that?
Yeah, no, I think that's exactly right, Mark. And just put some numbers on it. A VIP helicopter exiting the Hamptons can climb out about 1,500 feet per minute and it needs to be going forward to do that.
Right.
The VI can go straight up at over 4,500 feet per minute at max gross. So we can be out of earshot in under 30 seconds. And part of the operating model for our aircraft is never low and loud over people. So we won't promote landing on rooftop helipads because you're going to be bothering people nearby. There are underutilized public resources that this aircraft gives us access to. Mark talked about the airspace between, sort of 12,000, 20,000 feet. That's currently not really used by anybody.
Right.
VI is designed to make use of that airspace. That's where it's happy. And similarly, I talked about waterfronts. So in operating out of cities, most major cities in the world were developed around water-based transportation. And 150 years ago, those were full of docks and a forest of masts, and now they're empty. We can bring some life back to that and use it as a transportation resource. And that means that our approaches, anytime we're down low, for the brief time we're down low, we're out over the water. So,
Okay.
These are real concerns people have, and we respect those, and we've taken them heavily into account in the design. Another thing I want to point out is it's well understood by rotorcraft pros that the tail rotor on a helicopter is the noisiest part of it. If you've ever been in a real big aircraft shop or hangar where people are doing maintenance, you'll have seen they don't have a bunch of little box fans around blowing air around to cool them. They've got a giant, very slow turning helicopter rotor sized fan on the ceiling that turns slowly to move the air. So one of the problems with distributed electric propulsion is it pushes people to use a lot of small fans. Small fans are more noisy. So one of the advantages of our design is that we've got two big propellers that we turn pretty slowly. The tip speed is 0.5 Mach in the hover. And I'm told by experts that means that's quiet.
Sure.
Below 0.6 is considered to be good. So I don't expect the VI, it's going to make noise. It's going to sound something like a King Air. But it's not going to have that low frequency whop, whop, whop that helicopters have, that people hear coming, that, radar from MASH used to hear, that, annoys people in their houses. It won't have that. Our model is we're going to come in over the Hamptons really high and basically come straight down. And then we're going to depart straight up and go out of there. We won't be over anybody's houses.
Gotcha. So tell me about, so you're saying entry into service in 2025.
That's the goal. Yep.
You've got some prototypes flying now.
Yep.
When do you think you transition from prototypes into building a full scale aircraft? Are you 2021, 2022 by the time you do that?
Yep. No, end of 2021 would be when we should have, if we get funded, in the time frame I'm hoping we will right now. End of 2021, we should have a full-scale manned prototype aircraft turning propellers.
Okay.
And we should be more or less done with flight test of that and another aircraft and ground test vehicle later, mid 2022 kind of time frame.
Okay.
Yep.
And then entry service 2025. It's pretty exciting. It's an exciting project. I mean, it's
yeah. Well, can I say one other thing I'm excited about?
Yeah, please.
So we did trade studies, as one does, and we looked at electric propulsion. There's some nice advantages to having electric motors in the nacelles driving your propellers.
Sure.
It turns out that putting motors out in the nacelles and power wires running out there versus mechanical drivetrains and gearboxes is actually heavier. It's lighter to do it mechanically. Because, people's intuition is that electric wires are small and light, but not when you're putting most of a megawatt through them.
Right. Yeah. It's a big bundle.
Yeah. Well, and you can go high voltage to try and reduce the current load, but then you've got arcing questions. I mean, it's hard. And there are people who are solving that problem, but it turns out in our trade studies, it's less weight to put the mechanical drivetrain. And it's a simple mechanical drivetrain. It's not like a helicopter rotor head. It's orders of magnitude, literally orders of magnitude less complex. So to electrify a VI, when the day comes that there's been a breakthrough in battery technology, we simply take the jet engine out, we put a big electric motor in its place, turning the same drivetrain. Take the fuel tank out, we put batteries in its place. Those have all been designed into the CG so we can do this. We'll be able to electrify VIs in the field via an STC because none of the performance is going to change.
Okay.
So that's something else I'm excited about because, like I said, we agree the future's electric. We just don't know when it's going to be here. And we don't want to place that bet right now. We don't have to. We've got a design where we can start out with turbine and we can go to electric seamlessly when it comes.
And that's one of the things that attracted me, Craig, as an operator, that just the kind of the forward-looking plan to maximize the ability to do the mission with this aircraft is just phenomenal. And I might add too, on Rotorcraft Newco, we expect to be operational with our first acquisition by the end of June.
Yeah, you and I talked a little bit about that, and we'll keep that to ourselves. But sounds like you guys got some exciting plans down the road.
We do, absolutely.
So good. So I'll look forward to seeing some great press releases out of both of you guys with Rotorcraft Newco and Transcend Air.
Yep.
Website is Transcend, TRANSCEND.aero. Am I correct, Peter?
AERO. Yep, that's the
AERO.
website. And we also feature our VIP aircraft configuration at vi400.com.
Okay, vy400.com.
Yep, vy400.com.
Great. Thanks for coming on, guys. It sounds like some great new stuff coming out in urban mobility.
Yeah, we're looking forward to having us.
Watching your progress.
Thank you.
Thanks
Awesome.
a lot, Craig.
I hope you enjoyed the latest edition of the Aerospace Executive Podcast. You can reach out to me directly, Craig at northstaresg.com, or check us out at www.northstaresg.com. You can subscribe to this podcast on iTunes, Stitcher, Podbean, or on YouTube. Just do a search for Aerospace Executive Podcast. Thanks again. I'm Craig Piven.